Okay, now since this chapter is so easy, I'm teasing about that, but we know how to use ifs and if-else's and stuff like that. We're going to go again and do a little bit more about object-oriented programming, but we're going to use a class rather than a structure. A class, like a structure, has variables in it, but it also has functions. So I'm going to grab my boilerplate, make a new project. But not a C# project.
C#. Let's go back to slides.
Lecture L. Solution Explorer, right click, add new item. Lecture L.cpp. I know you know how to do all this stuff, but I'll get lost if I don't talk a lot. Alrighty, there we go. There we have our boilerplate place. So last time we had a patient class with some pieces of data in it. This one's going to be even simpler. It's just going to be a square with a single variable in it, which is the side length of a square, right? It's all it takes to specify a square. So class, capital S square, open curly brace. Now it's only got one variable in it, a side length. However, we need an extra keyword here that we did not with a structure. It says public colon. By the way, Parker, when we do this in Java, you leave off the colon. So what this means is that variable will be accessible to main. I'm going to change hello to lecture L. Alrighty. Anyways, let's make a square. Square S1 equals new square, parentheses in parentheses, semicolon. And I didn't do the trick. So I'm just going to delete all that and leave it like this, square S1, semicolon. And I'm going to set the side of it, S1.side equals 10. It's going to be a 10 by 10 square. Now, we know how to calculate the area of a square. It's just a side times a side, right? So we could do that. Double area equals S1.side times S1.side, or you could use math.pow. But it would be more awesome if we could do this. Double area equals S1.area, like that, parentheses in parentheses. And double perimeter, which is a distance around the square, perimeter equals S1.perimeter, like that. So these are going to be functions that are attached to the class. A function that's attached to a class is called a method. So we're going to go and add two methods to our class. And again, since we're hitting this before the book does, it's okay if this doesn't make 100% sense. It's okay if it only makes 10% sense. It'll make 20 the next time, and 50 the next time, and then 100. So these things need to return a double in order to be stored in a variable of type double. So double space area, parentheses in parentheses. And on the next line, we need a curly brace. And we need to calculate the area and return it. I wonder if this is going to work. double space area equals, something's bugging me about this. I want to make a few changes, and I'm so sorry for that. Make this one called get underscore area. And make this one say get underscore perimeter. And then up here, make this say double space get underscore area. And so we'll say double area equals this hyphen greater than side times this hyphen greater than side, semicolon. And the next line needs to be return area, semicolon. Do another one. Let's do get perimeter. Got get perimeter called down here, we better provide it. It's a function that's attached to our S1 object. S1 is a square, so it's going to be a method that's part of the square class. Double space get underscore perimeter, parentheses in parentheses, semicolon. Same business, except the perimeter is 2 times the side plus 2 times the width. So double space perim, just so I don't have to type out the whole word each time, equals 2 times this hyphen greater than side. No, it's actually just 4 times the side, right? It's square. So it's 4 times this hyphen greater than side, semicolon, and then return perim. See what we're doing? Instead of adding functions directly in our code, we're making them part of the class. These are called methods. Method is a function that's part of a class. Some languages don't even have functions. All they have are methods. Java is like that. There's no way you can write a function that's not part of a class. And so get area calculates the area and returns it. The get underscore area method calculates and returns the area. And same for get perimeter. I don't think we need to add a comment for that. Yeah, we could. The get underscore perimeter method calculates and returns the perimeter. Now the code should work, or at least it'll compile and run. We don't have any output, so it's not going to do anything cool. But it'll compile and run if I haven't made any mistakes. All right. Why don't we print those values out? So down here, after we calculate the area and the perimeter, let's just print those out. Cout less than quote, triangle side equals end quote, less than S1 dot side semicolon. And then just copy and paste that and make it say triangle area and triangle perimeter. So triangle area equals S1 dot get underscore area parentheses in parentheses, just like a function. We're calling a function that's attached to our S1 object. And then triangle perimeter, this is our third one, triangle perimeter equals end quote, less than S1 dot get underscore perimeter, parentheses in parentheses. Now I'm not going to explain yet why we had to use hyphen greater than up here to access side, but we use a dot here. Just kind of accept it on faith for now. Wait, where'd my side line go?
Yes, we changed.
I changed it. Well, there. And I need some ENDLs. So before my semicolons, ENDL, ENDL, ENDL. There we go. Side length is 10, the area is 100, the perimeter is 40. Looks good. I think that's about enough to go with this example. But what have you seen? That an object can carry one or more pieces of data? This one just has one, but we could have made one that had, you know, two, a height and a width. Or what if it was a block, a 3D block, a height, a width, and a depth, right? What if it was a drawing program and you wanted to put this square somewhere on the screen? You might need to record its X and its Y location. So there might be a whole bunch of variables declared up here. But we only have one. That's enough. And then we access the pieces of the object with this dot nomenclature. The side of this square. We call the getArea method of the square. And then we could make a different square, right? We could do this. S, capital S, square, S2, semicolon, S2 dot side equals, 75.3, semicolon. You know what? We can delete these two lines. We never use them, do we? We never use area, and we never use perimeter. We just call them directly like that. So I think I'm going to delete those two lines. Or I could leave them there. But what I want to do is I want to copy these three statements, paste them, but change all the S1s to S2s. So when we run it now, we'll see that square 1 and square 2 have different areas, and so on, right? Why am I calling them triangles? Replace every word triangle with square. What's a fast way of doing search and replace if you're in Visual Studio? Hit Control H. Yeah, Control F will do a find. Control H will do a search and replace. So Control H, search for the word triangle, replace it with the word square, and you see this thing right here? That does a replace all. Alrighty, I don't know where my brain was. Probably because my next example usually is a triangle. Good enough. We could also incorporate this idea into the idea of a circle, right? And get the perimeter of the circle or the area of the circle. It's not called perimeter, is it? It's called the circumference. Get the diameter of it, or we can make it a sphere and get the volume of it. But I think that's taking the example far enough. Anybody need typo correction or more time to type?
A little more time.
So if, else, if. If it is raining, take the umbrella. Else, if it is windy, take the hat. Else, take your sunglasses. If expression, do something. Else if expression, do something else. Else if, do something else. And if you have a series of else ifs, even though they don't show it, you should always put just a final else to handle everything else. No pun intended. Just kind of as an error check, right? Because we might not handle every case from here to here, even if we think we did. So for example, test score. If your test score is greater than an A score, print A. Else if your test score is greater than a B, print your grade as B. Else if test score greater or equals C score, your grade's a C. Else if test score is greater or equal to D, print D. Else, and here's your final else, just like I said, anytime you have a series of else ifs, there should be a final else. If you've taken Python, you know elif with no spaces between them. Yeah, there is no elif in C or C++, so you make it else space if. So this is called a trailing else. The else without the if It just catches invalid test scores, right? All of these would print out A, B, C, D, or F, but what if they entered a -20? Well, that's an invalid test score. Flags. A flag is a variable that signals a condition, usually implemented as a Boolean variable. It's either equal to true or false. Something like this. Let's ask them to enter a number between, firstly, let's just assign a temperature variable. And Parker, this is going to sound very familiar to you because we're at the same point in Java. Int space temp F, the temperature in Fahrenheit, is equal to, I don't know, 109. It's really hot. Now we're going to find out if that's hot. So bool space hot equals, and the parentheses here are not necessary. I'm going to go ahead and put them because I think it makes it easier to read, but they're not. Bool hot equals, and inside the parentheses I'm going to do temp F greater than equal to 100 degrees in parentheses semicolon. I could take the parentheses away. I like the way it looks better with the parentheses. Maybe you like it better without. To me, that kind of implies, okay, you're going to do this. And what is this? This is like an if statement that returns a true or false. Is the temperature greater than 100? Yeah, then put true inside hot. Now we're going to have an if statement. If it's hot, if parentheses hot, cout quote, wow, it's hot. Turn on the AC, exclamation point, \n, end quote, semicolon. So this is what's known as a flag, or Boolean variable. It contains a true false, and you use that true false to trigger some action later. Boolean variable, also known as a flag, contains a true or false and is used to trigger an action later. Like this. If it was hot, we tell them to turn on the air conditioner. So now we're going to check. We're going to have our AC on. So if parentheses hot in parentheses, curly brace, let's print out the current temperature. Cout ~, quote, AC running, semicolon, temp F equals, space, end quote, ~, ENDL, we haven't printed out the temperature yet. Get rid of that ENDL. ~, temp F, ENDL. Now we're going to subtract 1 from the temperature. Hot minus minus. No, that's not right. Temp F minus minus. Temp F minus minus. And now we're going to set our flag again. Should we keep the AC running? But you know, it'd be really annoying if your AC turned on every time it was 100 and then turned off when it was 99 and turned on when it was 100 and turned off when it was 99. Instead, we're going to say keep running until it gets below 75. So hot equals, single equal, not double like I accidentally typed, temp F greater than or equal to 75. Keep running until it drops below 75. It's hot if the temperature is still greater than 75. And I made a bad mistake, and it's the same mistake I made when I was... That needs to be a while loop, and we're not even talking about while loops, and I forgot that. But I just demonstrated one anyways. What is a while loop? It's a chunk of code that keeps running as long as the condition is true. An if statement just marks some code and it says, okay, if that's true, do it. While says, if this is true, keep doing it over and over and over as long as it is true. You've had fundamentals most likely, so you already know what a while loop is. I don't need to stress that I didn't show it. Okay, so it was 101. It was 110 degrees. We turned on the AC. It kept on until it finally hit 75, and we were cool. So we could do the grade example that they've got. I don't see a reason to do that. But let's set the temperature equal to something else. I don't know what. Temperature F is equal to, I don't know, how about negative 10 degrees. It got really cold all of a sudden. So what we're going to do is this. If temp F greater than or equal to 212, it's really hot. The temperature at which water boils at standard pressure is 212 degrees. So if the temperature is greater than or equal to 212, C out less than, quote, boiling hot, \n, semicolon. And if you wanted to jump in, here's be a good point to do it. You could just start with that. Else if temperature F is less than or equal to 32, it's freezing. Close parentheses, C out less than, quote, freezing cold, \n. And then one final else, because it might not be boiling, it might not be super cold, so else, C out less than, not boiling or freezing. Yes, sir.
Could you print that off for me? I walked in a little late.
Oh, yeah, sure. \n in semicolon. Now remember, you don't have to type in the lecture, but I know it's cool to do it. It burns it in your brain. That's my goal.
Thank you.
Certainly.
Mr. Thompson?
Yes, sir.
Yeah. Okay, so it won't let me, on the earlier part, it wouldn't let me define my square S2 class.
Okay, let me come look. Let me pause.
Oh, we're all talking about classes now, aren't we?
Yeah, you'll want to watch. Now, some folks are tempted to do things like this. Like if you were going to write a grade program. I'm not going to write the entire grade program. But what if we did this? Int grade equals, 89, semicolon. Some people will go to some effort about their if statements. If grade less than or equal to 100, ampersand it, and grade greater than or equal to 90, close parentheses, C out double quote, C out arrow, quote A, \n, end quote, semicolon. Else if grade is less than 90, ampersand grade greater than or equal to 89, C out less than, quote, B, \n, end quote, semicolon. That's way too much trouble. You don't need to have this many statements here. You don't need to be checking your ranges that way. That's just going to cause problems. What if your professor decides to give you an A if you make an 88 or above? You got to change it in multiple places. A better way to do it is just this. I mean, maybe the first one's okay. Maybe you want to cap your grades at 100, but what if your professor gives you extra credit and you can make 105? So, if parentheses grade greater than or equal to 90 in parentheses, C out less than, quote, A \n, end quote, semicolon. else if parentheses grade greater than or equal to 80 in parentheses, cout arrow arrow quote b backslash n end quote semicolon. And yeah, we could put these couts on their own lines, right? And so on, right? And then just 70 and 60 and 50 and 40. Don't do it this way, right? We don't need to be checking both the other lower and upper range if we can just stack them like this. Else if parentheses grade greater than or equal to 70. That's all we're going to do. Or maybe we'll throw in a final else to get them, you know, an F. I guess it wouldn't take that long. Tell you what I'm going to do. I'm just going to copy those two statements and paste it twice. So I can make that a 70 and a 60 and a C and a D. Numerical copy paste. And then else cout less than quote F backslash n end quote. That's a lot cleaner than it would have looked if we kept doing it like that. So I'm going to add a comment up here. This code is very messy. This code is much better. Excuse me. Thank you.
Oh.
What if we forgot to use else if, on the other hand? Since this code is messy, I'm just going to comment it out. I don't want it around anymore. And I don't want you to make this change, but I want you to see what happens if I remove these else's. Their grade is 89. What's it going to print? Well, if grade is greater than 80, yeah, Minketer knows where this is going. It's going to print a B. But is their grade greater than 70? If it's 89, it's certainly greater than 80, so it's going to print a B, but is it also greater than 70? Yep. Yep, so it's also going to print C. Is it greater than 60? Yep, so it's also going to print D. We don't want that. Right. So that's why we use else if, to make them so-called mutually exclusive, so that only one of these things will be done, not multiples. So logical operators, and, or, and not. You just saw me use and up here. We've talked about and, is that correct?
Yeah, we did.
Okay. So if you have and, its symbol is ampersand, ampersand. So if you have x and y and then a result, if you have a false and a false, then that results in a false, because and means both sides have to be true. If you have a false and a true, well, both sides of them aren't true yet, so it's still false. If you have a true and a false, what? Both sides aren't true, still a false. And then finally, if you have a true and a true, you get a true. You could replace all those F's with zeros and all the T's with ones, and you get the same chart. This is called a truth table. Truth table for and. You really don't have to type all this unless you just really feel ambitious. The truth table for or. What's the symbol for or? I know I've said it. I bet you can remember.
Only one true is true.
Yep, the vertical bars. Yep. So or is done with vertical bars like that. Shift to the backslash. So x or y and the result. False or false. Well, neither side is true, so it can't be true. But or means either one or the other, or both. So if we have false or true, that's a true. True or false is a true. And then true and true, well, it's doubly true. That's a true. So you write expressions like this, right? A greater than 10, ampersand, ampersand, A not equal to B. Let's figure out if that's true or false. What if A was 11? And what if B was equal to 12? Is this true or false? Well, we just have to figure it out. And means both sides have to be true. Is this side true?
True.
Is this side true?
True.
What does this thing mean right there?
Not equal.
Right, so is it true that A is not equal to B?
Nope.
Is it?
Well, yeah.
Yeah, it's definitely true that A is not equal to B. So this part's true and this part's true. And so it's definitely the whole things are true. How about if we have A equal B or A equals C? No, wait, there is no C. A equals 20. Is that true or false? Well, is A equal to B?
No.
Nope. Is A equal to 20?
No.
Nope.
It's false.
Definitely false.
Finally, I get to see where all those logic math classes apply.
Yeah. Yeah, if you've done your computer engineering, then you're used to using those other symbols. You know, AND gates and OR gates.
Well, I haven't even taken it yet.
Oh, okay, but yeah, like that. This is how you draw it in electrical engineering. A and B.
Digital signals. Yeah, that's what we do sometimes.
Yep.
But we're not there.
So instead of true and false, it uses zeros, right? But this is an and so 0 and 0. The only time and is true is when both inputs are 1. So 0 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0. Finally, we get to something that's true. 1 and 1 is 1.
You know what's strange though? For electrical engineers, they don't make them take discrete maths or structures.
Yeah, and they should. Discrete math should definitely be part of the engineering toolkit.
Oh yeah, they have it for the CS guys, but
Alrighty, so now we know what a truth table for and, a truth table for or, and finally the truth table for not. Not x result. If x is true, then the result is false. If x is false, the result is true. So what if we do this? Not a equals b or a less than b. I don't know why we'd write it like this, but just roll with it. Okay. You got to do the part in the parentheses first. And is a equal b?
No.
Nope. So is a less than b?
Yes.
Okay, and is this an and or an or? It's an or. So what is this totally equal right there?
True.
And then the not turns it into a false. Yep.
Like right away. False, 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 false.
We could work through their examples, but they already have the answers here. Woohoo! Now we don't. All right. X is 12, Y is 5, and Z is -4. It'll help if we just remember that X is the largest and Z is the smallest. So is X greater than Y?
Yeah.
Yeah. Is Y greater than Z?
Yeah.
So both sides are true, so the result is true. Is X greater than Y?
Yeah.
Is Z greater than Y?
No.
No.
Nope. So that's, since and
definitely
requires them
false.
both to be true, yep, you got it. It's not true, it's false. Is X less than or equal to Z? Heck no, X is not less than or equal to Z. Is is Y equal to Z?
No.
No. And so regardless of whether that was and or, that's definitely a false. All right, now they got to get a little wilder with us and throw a not equal in, but I did the same thing. Is X less than or equal to Z?
No.
Nope, so that's a false. Is it true that y is not equal to z?
True.
Yes.
That is true, and since it's an or, only one side has to be true for the result to be true, so that's definitely true. And lastly, is x greater than z?
Yes.
Yes.
Yes, but then that makes it a false, so it's not.
True, false, false, true, false.
Logical operator notes, exclamation mark has the highest precedence, followed by ampersand, followed by or. Why does ampersand have the highest precedence? Because it's akin to multiplication. What do I mean by that? I'm going to copy this and replace them with zeros and ones. 0, 0, 1, 1, 0, 1, 0, 1, 1, 0, 0, 0. No, wait, that's not right. 0, 1, nope, that's still not right. What should these four answers be in order? 1, 2, 3, 4. What should they be in order?
1 is 1.
Well, if you have 0 and 0, you have false and false. What's the result?
True.
Nope, false and false is not true.
Oh, false.
Yeah, yeah. And then so false and true, is that true or false?
False.
Then in that case, true and false is still false, and true is the only time that's one. Okay, if you look at this, this looks like multiplication. 0 times 0 is 0. 0 times 1, still 0. 1 times 0, still 0. 1 times 1, 1.
Is this like the conversion to Boolean and binary operators?
Yeah, exactly. So and is akin to multiplication, or it's and, let's do and is logical multiplication. If you ever take a logic course, then you will see that when they write things like that, AB, it means A and B. Well, if and is logical multiplication, I think I spelled that wrong, then or is logical addition. I'm going to go and copy the or table and turn them into trues and falses. All right, again, the F's become zeros. The T's become ones. What about these answers? Somebody tell me these numbers. If you have 0 or 0, what's the result?
False.
False.
Still false. How about 0 or 1?
True.
Yeah, and the rest of them are all 1. Okay, that's addition. 0 plus 0 is 0. 0 plus 1, and I know we've seen this before because we talked about bitwise, so this is the second time you've seen it. 0 plus 1 is 1, 1 plus 0 is 1, and then 1 plus 1 is, well, you'd think it was 2, but this is a logical world where you either have only 2 values. Something is true or false, so that's 1. And since multiplication has higher precedence than addition, then and has higher precedence than or.
Okay, straight up.
Let's go back to our example. If you have A is equal to 11, you have B is equal to 12, and you write this. If, no, A equals 11, or A equals 12. No, I'm going to change that. No, I'm not. I'm just going to make it up, and I don't care. And A equals B. Changing my mind. Rewriting it.
What's going on here?
Finally. Okay. I think I've got this the way I want it. Is this true or false? Well, just like multiplication has to be done first, this part has to be done first. Is A equal to B?
No.
How about this? A equals 11.
Yes.
Okay, so A equals B and A equals, well, this was an and, so is this entire part true or false?
It'd be false.
It'd be false, and then we have a false on that side, and what do we have over here? Is that true or false?
That's false.
And so false or false equals false. As long as you remember you have to do the ands first, then you're good. And honestly, if I was going to write something like this, if, and put all that in there, I would go ahead and put extra parentheses around that part just to make it clear. Even though you don't have to, right? It would calculate the same way whether you did or not. So there's something called short circuit evaluation, which sounds bad. Who else is going to short circuit? It's not bad. Let me give you an example of it. What if you had this? If A equals 11, and then you had an if statement in here. If B equals 11, then C out yes. If this is true, we have to check this, right? But if this is not true, it doesn't even bother checking this. Why check this if this is not true, right? If that's not true, it doesn't come in here and do that. So if you write this, but if you rewrite it as an and, if A equals 11 ampersand B equals 11 in parentheses, C out yes. That's the same logic, right? It'll do the same thing. It'll give you the same output. I hope you agree. Well, if this part is not true, it doesn't bother doing that part. Doesn't need to. Just like if this wasn't true, it doesn't bother doing that. That's called short circuiting. If this is not true, it skips this part. So let's write that down.
I have a question.
Yes, sir.
Does that mean we need to change our logic operators if it short circuits, or would it?
Well, see, short circuit makes it sound bad. And no, short circuiting is great. It's a way of speeding up your comparisons.
Oh, okay.
And the reason it speeds it up is that if you have two calculations, then you put the one that is false most often true. Why? So that you can rule out as many cases as possible. Because if this one is true, this one also has to be evaluated, right? If the first part is true, it has to check the second one. But if the first one is false, it doesn't even get to, and that speeds things up. So you put the thing that is false most often true. So short circuiting of and. If the first expression is false, the second one is skipped. This saves time. That's why it does it. So put the expression that is false more often first. How about or? Or works the opposite way. If A equals 11 or B is equal to 11, then C out yes. The way or works, if this part is true, what do you know about the whole expression? If this part is true, is the whole expression true?
Yeah.
Yeah, so why even bother doing that? It skips that part, which is good. It speeds it up. The fewer comparisons, each comparison takes, a couple nanoseconds. If you're really trying to write fast code, you take advantage of short circuiting. C++ is a fast language, unlike Java or Python, so it's worth thinking of these things. So short circuiting of or. If the first expression is true, the second one is skipped. Again, this saves time. So put the expression that is true most often first. I'm not sure I put those questions in the quiz, and I think I should. But just remember short circuiting. If it's and, if this part's false, it doesn't do that one, and that saves it time. If it's or, if this part is true, it doesn't do that one, and that saves time.
President Thompson,
Yes, sir.
I can't get mine to work. I don't know what's going on.
Which part? The code you were typing in a minute ago? I mean, the.
Hey, Mr. Thompson.
Yes, sir. Aha! Checking numeric ranges with logical operators. You use AND to see if something is within a range. You use OR to see if it's outside of the range. Let's actually put this in our code because we had this temperature F stuff.
Okay.
Above our grade stuff, I'm going to put this example. Use AND to check inside a range. Use OR to check outside a range. It's like this. If temp F greater than 32, ampersand, ampersand, temp F less than 212, Cout less than, quote, liquid, \n, end quote, semicolon. So we just checked to see if it's within that range. Now we're going to check to see if it's outside that range. If temp F less than or equal to 32, or it's greater than 212, if temp F greater than or equal to 212, then it's not a liquid, right? It's either boiling or freezing. Cout less than, quote, not a liquid. Either boiling or freezing, \n, end quote, semicolon. Make sure that works.
The midterm is due on the 17th.
I'm so sorry, pardon?
The midterm is due on the 15th or the 17th.
I don't know.
You sent in an email. I read it yesterday, but I don't remember.
Can't be the 17th. That's spring break, I believe.
Fall break.
Well, whichever. It's break. It'd have to be 15. But let's see that I said in my email. Let's go look. '15th and 17th of fall break. Yeah. Alrighty. Menus. Menu-driven programming. Program controlled by the user selecting from a list of actions. Didn't we do something like this where we asked what element, and then if it was a certain element, we set the atomic weight? Is that sounding familiar, or did we not do that?
Your Java class, I think.
Yeah, okay. So, a menu-driven program. We could do something like this. And it'll be the last thing we do today. Cout less than, quote, one equals small, comma, 2 equals medium, comma, 3 equals large. \n, end quote, semicolon. Now let's declare a variable to hold the choice. So int size underscore choice. Now let's tell them to type in one of those values. Cout, pick a size for your box. Colon, space, end quote, semicolon. I'm going to move this Cout statement below the int size choice just so it looks cooler. And then cin greater than size underscore choice, semicolon. All right. Now we know how big the box is. Let's ask them what we want the box to be made out of. Now I don't know anything about wood. What kind of wood is more expensive?
What?
Lignum, mahogany. All right, we're just going to make it up. We're going to say that oak is expensive and pine is not. So
Mahogany is expensive.
mahogany is?
Yeah.
Yeah, okay. So int wood underscore choice, semicolon. Cout less than quote, 1 equals pine, comma, 2 equals oak, comma, 3 equals mahogany, backslash n, end quote, semicolon.
Now, I'm done with this part. Now you finish.
Cout less than quote, pick a wood for your box, colon, space, space, end quote, semicolon. And we're going to read in our answer into that wood choice variable. So CIN greater than wood underscore choice, semicolon. Now we need to turn those choices into actual values. So we're going to use some if-else's. We need a variable to hold the size, and we need a variable to hold the cost of that size of wood. So int size underscore cost, semicolon, int wood underscore cost, semicolon, and I'm going to add a parenthetical. Total cost is size underscore cost times wood underscore cost, semicolon. That's where we're going with this, right? So if it's a medium, if these exactly equaled each other, it'd be 2 times 2 is 4, but we're not going to make it exactly like that. So if, parentheses, size underscore cost, wait, sorry, delete that. If size underscore choice equals 1, in parentheses, then it's a small box. And so size underscore cost equals $10. Else if size underscore choice equals 2, in parentheses, I'm going to take these curly braces out. Then the size cost equals 20, semicolon. And then if it's a large box, it costs even more. Else if underscore or parentheses size underscore choice equals 3, in parentheses, then the size underscore cost equals $40. Doubles each time. We're going to do the same thing for the wood choice. But we need a final else to handle an error case. What if they type in something stupid like 4? Else, curly brace, they chose something invalid. Cout less than invalid size, semicolon, assuming large, period, backslash n. Right? If they pick something dumb, we're going to charge them the most. Size underscore cost equals 40. I'm going to make sure I don't have any syntax errors because we've typed a lot. All right, pick a size for your box 1. Pick a wood for your box 2. All right, I don't have any syntax errors. That doesn't mean that you don't. Anybody getting syntax errors that they would like help with? Nope, you're still typing. I don't blame you. Do the same thing for wood cost and wood choice, except make wood 1 cost $5, wood 2 cost $6, and wood 3 cost $7. 5, 6, and 7 for our 3 choices. So if wood underscore choice equals 1, then the wood underscore cost equals 5, semicolon. else if parentheses wood underscore choice equals 2 in parentheses, wood underscore cost equals 6. Else if underscore wood underscore choice equals 3 in parentheses. Then wood underscore cost equals 7, semicolon. And finally, if they didn't pick 1, 2, or 3, it's an error, right? So else, curly brace, we're going to yell at them again. Cout quote, invalid wood choice, semicolon, and then we're going to charge them most, assuming mahogany. Mahogany. I may be spelling that wrong.
OGANY.
Okay, M-O-G-A-N. Yeah, I misspelled it right. Assuming mahogany. And I made the same mistake up here. Should be mahogany. All right, and so if they made an invalid choice, we're going to set wood underscore cost equals 7.
Oh wait, you're supposed to put in
Oh, I forgot my backslash n, end quote, semicolon. Now we're going to calculate the total price. Double space total underscore price is equal to the size underscore cost times the wood underscore cost.
So I gotta submit what I have.
And then Cout, let's print the total cost. Total cost of box equals, end quote, less than, let's put a $sign there to be fancy.
So it says right here that it's $28 per board foot for mahogany.
Oh yeah?
And it's about $3 per board foot for regular cherry wood.
Ah, yeah. Yeah. So $, end quote, less than, total underscore price, less than ENDL. So menu-based programs, right? This isn't exactly what the book shows as an example of a menu-based program, but it's similar, right? We display a little menu and we let them pick a choice. Again, I'm going to run it and make sure it works. But I'm going to type in invalid values. 10 for the size. It's going to yell at me. And well, it will in a minute. Pick a wood for your box. Again, 10. It's going to say invalid size, assuming large. Invalid wood, assuming mahogany. Total cost is $280. And then for some reason we have a B down there. I must have some if statement or grades. Oh yeah, that's the grade stuff. So there's our example of a menu-based program.
Is there any way for us to turn in Lecture L? Is there anywhere on Canvas?
Not yet.
Okay.
So, I mean, it will be.
Oh,
Do you need it right now, or are we going to wait a minute?
I
Can
was
we wait a
asking
minute?
Because it's 9:45.
Yeah, we're going to stop. But I'm going to show you all the homework assignment first, which is almost exactly what we just did here.
Homework assignment? And it's due on Wednesday. Are two assignments due on Wednesday?
You got to be doing Wednesday.
Oh.
Next Wednesday. Next Wednesday is not spring break, so. Okay, so you're going to write a program that asks for the diameter of a sphere and what material it is made out of, and it will calculate and print the mass. Specifically, the diameters are based on these shapes. A marble is 0.05 feet, it's very small. A beach ball is 1.67 feet, it's big. And then you have some ice. Ice is very light, relatively. It's 55 pounds per square foot. Wood is even less than that, which is why it floats. Gold is heavy as all get out. It's 1,200 pounds per cubic foot, which is why those video games where you find like, you know, a chest filled with gold, you can't even imagine how much a chest filled with gold would. If it had 2 cubic feet of gold, it'd weigh more than a ton. So your adventurer would not be able to drag it around. And osmium is even heavier than that. I believe it's the heaviest naturally occurring element. So here's how it's supposed to work. Welcome to the sphere mass calculator. It displays this and it asks what is the diameter of the sphere. And so they choose baseball. Then it displays a menu of the materials. What is the material? They choose gold. They want a gold baseball. And so then it calculates the volume and the mass by the equations, the formula specified up here. You got to calculate the radius. You got to calculate the volume. It's easy. You just copy and paste these formulas, and then you copy the mass. So even if you don't get the math involved, you just copy and paste the formulas, and you're good to go. And if you still can't get them, I'll write them out, you know, in an algorithmic form for you. That makes sense?
Yep.
How about you, Serena? You agree?
Yep.
Parker?
Yeah.
We all agree. All righty. We've taken a vote. Dropbox time.